it travels fast. Y is heavy and it travels slow. Driver applies the brakes for a short interval. They experience the same force over the same time. Neither one comes to a complete stop, and then which is true regarding loss of kinetic energy. So, what do you think?
I put A.
You did.
Was it right?
Yeah. Tell me why.
Because kinetic energy is like energy due to movement. So if it's going faster and slows down, like, it loses on movement.
They both have the same force. Both have the same force. The force is applied for the same time. So you could say, and this question is not asking about momentum at all, but force times time. Do you remember that equation? F times delta T.
Oh, that's not right.
Impulse. Impulse, yeah. So they would have the same impulse. That's not what this is asking about. Change in energy is equal to the work that's done. Work, right? Do you remember the equation for work?
Change energy.
Okay, that's one of them. Yeah. The equation sheet says something like this, along these lines. Work equals change in energy, which equals FD, or FD cos theta, or something like that, right?
Yeah.
So we know between car X and car Y that the force is the same. But does that force act over the same distance? You see, the time is the same, but a car that's going faster
will still go
a greater distance. A greater distance means more work means a greater change in energy. So we got the right answer, but do you see how we piece that together? All right, that's good. So one is A, yeah. How about two?
C.
Okay, tell me why you pick C.
Because okay, so I was between A and C.
Okay.
Because of the E equals MVP. Because there wasn't a mechanical energy to the gravity really pulling it down.
Okay, so energy is conserved. The law of conservation of energy states that energy for a closed system is really constant. But if we were to say the law of conservation of mechanical energy, mechanical energy is conserved in the absence of friction. There cannot be any other external forces. So you have to pay very close attention to how they define the system. Okay?
Yeah.
If we define our system as the block, bucket, earth, that's everything.
Yeah.
Block, bucket, earth, and there's no friction. That means mechanical energy is constant. So for block, bucket, earth, with no friction, we should have no change in energy. And that to me looks like that could be D or B, because you see E, M, B, E, that's everything. So in B and D, that stays constant. Right?
Yeah.
So now we got to narrow it down between B and D. If we look at EME, that stands for the mechanical energy of the block Earth system. Initially, what does the block have?
Gravitational.
It's height above the floor, right?
Yeah.
At the end, does it still have the same gravitational potential energy?
Yep.
But what else happens at the end?
It stops.
Well, okay, it stops moving. It's not moving initially. How does it go from the left side to the right side of the table?
Straight.
Yes, but it had to move. If it had to move, it had velocity, right? And if it had velocity, it gained kinetic energy. It gained kinetic energy because if you just, okay, it's almost like the bucket doesn't exist. It does, but it's not part of our system. So the bucket's providing an external force by pulling on that string. The string pulls on the block to increase its energy. Okay?
So B.
B. Yep, because even though the gravitational potential energy stays the same, its kinetic energy is going to increase. Okay, 3. What do you got here?
I put A.
Yeah, A is correct. Can you tell me why?
I didn't like B because it was going downhill, which meant it was going to lose potential energy. I didn't like C because it just didn't make sense because it was going uphill due to gravity from natural force. It didn't make sense in my head.
Normal.
I was saying natural.
I tried to get him straight, but.
It's natural to say it,
It is natural.
but it's not normal to say it. Okay. So downhill, constant speed. Speed's not changing, so kinetic energy's not changing. But because you're going downhill,
Uphill, you're losing potential.
potential energy. The car travels uphill only under the influence of.
Gravity and normal force. I said that right. didn't
So
I?
what's going to happen if you do that?
Well, it wouldn't, would it? Because gravity accelerates downward. You wouldn't move, would you? You might, no. I don't understand how you travel upward.
A car and we want mechanical energy to increase.
Yes.
If a car goes uphill and only has gravity and the normal force acting on it, it's almost like, okay, you're driving your car
Yeah.
on a level road. You're at the base of a hill of a hill that you're gonna go up, right? Or you know what I mean? The road inclines now, but you threw your car in neutral.
Okay, I thought it started out on the hill and they would just
No. So the car would roll up the hill,
roll up the hill.
but you're trading speed for height.
Or height.
Yep, so kinetic energy
Kinetic
gets
energy
converted.
is lost.
It gets converted to potential.
Converted potential, yeah.
Yep, so, there's no increase in energy there.
Yes. And then in D, the car travels downhill, and then so you're changing potential into kinetic energy. So A is the only one that keeps potential going with kinetic energy.
Keeps the kinetic energy same, very good. Yep, I like it. About 4. What's going on here? Top of an 8-meter high incline. Upon reaching the bottom, it's observed to move at the speed of 10. How much work did friction do? How did you solve it?
Couldn't tell you.
Okay, so if there's no friction, we know that energy is conserved.
Mm-hmm.
And so we know at the top, it's at the top of a hill, it's gonna roll down, right? So here's our block, it's gonna go down this hill. At the top it has potential energy, at the bottom it has kinetic. Law of conservation of energy states that these two will be the same. So potential energy equals kinetic. Or mgh equals 1/2 mv squared. And so if we were to calculate these out, it's 2 kilograms, it's 8 meters high. Can we use 10 for G? Are you okay with that?
Yeah.
So 2 times 10 times 8, that's 160 joules to begin with.
Yeah.
Okay, does that equal, and then at the end, I'm kind of doing this a silly way. What I'm gonna do, because there is friction, so these are not gonna be equal. That was kind of weird to think about.
Yeah.
But what do we have over here? 1/2 mv squared. The mass is still 2.
Math is still 2.
So it's gonna be 1/2 times 2 times, what's the speed say?
The
Is it 10?
yeah.
At the bottom? 10 squared, right?
Yep.
10 squared is 100.
Yeah.
100 times 2 is 200. 200 times 1/2 is 100 joules. Okay, they're not equal. So how much did friction steal from us?
100.
Try again. We had 160 to start. Now we just have 100. Friction stole some energy. How much did it take?
It's all 60.
It's still 60 joules. Yeah. 60 joules. What I did, I should not have used, I'm gonna write this another way. Okay? Friction converts mechanical energy into heat. How much mechanical energy did we have at the top? Well, it was all potential energy,
Yep.
and that is MGH, and that came out, that came out to 160. How much mechanical energy do we have at the bottom? Again, this would be the exact same if there was no friction. It would be 160, we wouldn't even have to check. But they gave us some numbers. It's all kinetic energy down here, and that equals 1/2 mv squared. And when we just calculated that, it was 100 joules. So this and this are not equal. They're not equal because of friction. How much did friction take? 60 joules. That makes better sense to explain it that way.